Hello dear students, today I will discuss about new chapter, that is probability. Just last chapter of this maths syllabus of 11th class. Okay, so probability is very important for also 12th class. That's why I am taking this chapter now. And statistics chapter, in the previous chapter of this, I will discuss about on later on. Okay, so probability chapter is important. I think all of you are known about probability from 9th class, 10th class also. So here the probability, what is the definition of probability? Why we find probability? Probability means what? The measurement of uncertainty of any particular type of phenomena, like just like that events and something about an experiment. Okay, so measurement of uncertainty. Just in the previous class we have studied about probability, that finding a ratio, just like what a favorable number of cases, the cases favorable to the events divided by total number of cases. Total number of cases, that is cases means what? Outcomes. Whenever we do some experiment, some activities, that comes some, then there will come some result. That result is called what? Outcome of that experiment. So if an activity or an experiment shows some result, that is called outcomes, total number of outcomes in the denominator, and outcomes favorable to a particular event of our choice for which we want to find the certainty, whether it is probability, then we just write a ratio in the numerator, favorable cases, and in the denominator, total number of cases. And in that case, we are supposing that all these results, outcomes are equally likely. Equally likely means what? Equally likely means, suppose from an experiment we are getting different type of results, maybe just like throwing tossing a coin, we can get either head or tail. Okay, so equally likely means which outcome will come. We cannot give any reason for getting head or tail. That is equally likely. Their chances for coming same. Okay, but show the results show differently, either head or tail. So equally likely event means they are having same chance for coming. Okay, this type of supposition was there for finding probability. Okay, but and also we are seeing that the finding probability by using other method, by statistical approach also is there. The equally likely method, equally likely outcomes, by taking equally likely outcomes and getting probability by as a ratio, favorable cases upon total number of cases, these are called classical theory of probability. Now also we see in the previous class that statistical approach, by collecting data, and then also we get some probability. But In this case, in this type of cases, there may be difficulty for finding probability if the number of outcomes are infinite. That is, for an experiment, the get gives number of outcomes as infinite and not equally likely events. Then how can you find the probability? For that, the latest and another approach to finding probability is given by axiomatic approach. Okay, axiomatic approach to probability. Classical approach, statistical approach, and then axiomatic approach to probability. In this approach, there are many terms. Just we have to understand now that what is an event, what is an experiment, what is sample space. After knowing that terms, then we can find probability by the definition under this axiomatic approach. There are some examples. Okay, so one by one there are topics. That is, first is random experiment. Random experiment. First. Second, sample space. Outcomes. Second is outcomes. Third is sample space. Fourth is events. Events. Under this axiomatic approach, the random experiment, outcomes, and sample space, what events, and also different type of events and occurrence of events and types of events. They are the many different terms which are used for finding probability and defining probability under this axiomatic approach. Okay, so first of all we have to understand what is random experiment. And experiment is what? Just some activity we are doing. Okay, just like tossing a coin, throwing, rolling a die. Okay, and selecting a card from 52 cards. Also, and selecting a person from class 8 section B, etc. Okay, for different purpose. These are the activities. So doing this type of activity, that is an experiment. We can say that is an experiment. Okay, so experiment, random experiment. What is random experiment? Random, whenever we do some activity or experiment, we can get some result by doing this activity or experiment. Result, that is called also outcomes, but this result should be randomly can be occurred. Okay, so random experiment means what? Whenever we do some activity, then under identical condition we can do some activity and we can get result. But if this activity are repeating one time, two time, three time, four time, then the result, coming result may be different. Okay, so if under experiment we are getting results, a different type of results as we repeat this experiment, then this type of experiment is called a random experiment. Just like tossing a coin one time, we can get head or tail, and another time again toss, then we can get also tail or head. First time head and then second time tail, or first time tail, then second time tail, or first time head and then second time also head, first time tail and then second time also tail. Maybe different. So this type of event, this type of experiment is called a random experiment. That is, an experiment is called random experiment if it has more than one possible outcomes. Means not single outcome. That is here either head or tail, or if rolling a die, then we can get 6 numbers on 6 faces. Maybe any number come out as a result, 1 or 2 or 3 or 4 or 5 or 6. So more than one possible outcomes. And second is what? It is not possible to predict in advance that which number will come. That is random. Randomly may come any number. Randomly may come head or tail. So that is called a random experiment. It is random experiment, and experiment is called random experiment if it has more than one possible outcomes. It is not possible to predict in advance that which result will come. Okay, so this type of experiment is called random experiment. Generally, now we are concerning with experiment means random experiment. Okay. Outcomes, the possible results of an experiment or an activity are called outcomes. Just like tossing a coin, we can get the face having head or the face having tail. So they are the outcomes. How many outcomes are there? 2 outcomes, possible outcomes, head or tail. Rolling a die. So 6 faces, any of the faces can be on the top face by rolling a die. That is 1 or 2 or 3 or 4 or 5 or 6. These are the outcomes, 1 or 2 or 3 and so on, or 6. 6 outcomes are there. There are 2 outcomes for tossing a coin. So these are the called outcomes. Okay, and sample space. What is sample space? Whenever we do some experiment, that is random. Okay, that is random experiment. Its possible outcomes are denoted by some notation, and if all the possible outcomes are collecting and put in a set, that is called sample space. That is the collection of all the possible outcomes corresponding to an experiment is called sample space. That is tossing a coin 1 times. What will be the sample space? Head or tail? This 1 times. And tossing rolling a die 1, 2, 3, 4, 5, 6. They are the numbers on the faces. This sample space denoted by capital S. This sample is denoted. This sample space due to what? This sample space due to tossing a coin 1 times. This sample space rolling a die 1 times. Okay, so sample space is what? The set of all the possible outcomes. Set of all the possible outcomes. Okay. So first exercise is related to writing sample space. What is sample space? Set of all possible outcomes of a random experiment. Of a random experiment. Denoted by S. Okay, for tossing a coin, the sample space is given by what? Either head or tail we can get. 1 times. Okay. Similarly, for rolling a die, the sample space is given by what? S equals to any 6 number, out of 6 number, 1, 2, 3, 4, 5, 6. They are the sample space. Okay. 1, 2, 3, 4, 5, 6 are the numbers on the faces, head and tail for coin. So 1 time, single time, this is single time. Okay, sample space is what? The collection of all possible outcomes of an experiment. Okay. Now take first exercise, that is 16.1 exercise concerning with writing sample space. Okay, so how can we write sample space for an experiment or activity? Okay, so writing sample space is very important for finding probability also. So here we are trying to write all the sample space one by one. Okay, so just understand how can we write the sample space. So here 16.1 exercise, 16.1 exercise, first exercise, solution of first. Question 1. Okay, so here question 1, writing sample space. Describe the sample space for the indicated experiment. Here experiment is what? First question, experiment. On the basis of experiment we can write what may be the sample space for that experiment. So here a coin is tossed 3 times. A coin is tossed 3 times. A experiment. What is experiment? Experiment. A coin is tossed 3 times. A coin is tossed 3 times. A coin is tossed 3 times. Okay. So here just I will discuss about it. You have to write in very detail for at the time of writing sample space. Okay. So just we know sample space, that is S equals to, some notation is required for there. So here for simple writing of this first question, this experiment is this. Now we know coin is tossed 3 times. Okay. We know a coin has 2 faces, as head denoted by H and tail T. A coin has 2 faces as head and tail. Clear? 2 faces means one time tossing 2 outcomes. These 2 outcomes come simultaneously with 3 times, because 3 times tossed 3 times. So 3 times and 2 item are 3 times. That means How many outcomes will be possible? Total number of possible outcomes will be what? 2 items 3 times, that is 2 power 3. 6 items 2 times, that is 6 power 2. 2 power 3, 6 power 2, just like this. So, here this. So, three times tossing a coin will have total number of possible. So three times tossing a coin will have total number of possible outcomes. As 2 power 3 equals to 8. Okay? Thus, therefore, the sample space for this experiment is given by S equals to 8 elements will be there. Sample space is a set and all the elements are outcomes. So how many outcomes are there? 8 outcomes. So 8 elements will be there. So how can we write? Suppose 3 times we toss coin. So first time we can get head or tail. We can get head or tail. Clear? Now, first time. This is first time. Second time. What are the possibilities? First time we get head. And then second time. This is first time. This is first time. This is second time. And this is third time. First time. Second time. First time. Head or tail can get. At the second time, with this head, maybe head, tail. Second time, with this T, maybe head, tail. And third time, with this head, maybe head, tail. With this, maybe head, tail. With this, maybe head, tail. With this, maybe head, tail. 3 times. So our first, in 3 times, first H, H, H. So you can write first outcome H, H, H. And then H, H, T. H, H, T. And then H, T, H. H, T, H. And then H, T, T. H, T, T. And then T, H, H. T, H, H. And then T, H, T. T, H, T. And then T, T, H. T, T, H. And then T, T, T. T, T, T. These are the 8 elements. You can find by this tree diagram. 3 times tossing. So this is sample space. Okay? 1, 2, 3, 4, 5, 6, 7, 8. 8 items are there. Clear? So follow this rule: head or tail, with this head or tail, with this head or tail, with this tail, head or tail, in third time. First time, second time, third time. Okay. Simultaneously, if we toss 3 coins, also we can get this type of sample space. This is the sample space regarding corresponding to the first event. The coin is tossed 3 times. Okay. Question 2. So see our event. What will be the event is given here? A die is thrown 2 times. A die is thrown 2 times. Die having how many faces? 6 faces. Okay. The experiment. A die is thrown how many times? 2 times. We know die means what? A cube having 6 faces containing numbers from 1 to 6. That is, how many possibilities are there? 6. Okay. So, while throwing a die, the possible outcomes are, while throwing a die, the possible outcomes are what? 1, 2, 3, 4, 5 or 6. Okay. What? 1, 2, 3, 4, 5 or 6. These are the possible outcomes. Clear? Now, 2 times throwing die. So 2 times means first time and second time. First time we can get what? 1 or 2 or 3 or 4 or 5 or 6. This can be get. With this 1 second time we can get 1, 2, 3, 4, 5, 6. 1 or 2 or 3 and or 6. Similarly, same 1 or 2 or 3 or 6. Same as said. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. 6. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. So 6, 6, 6, 6, 6, 6 into 6, 36. So also 6 possibilities are 2 times. That is 6 for 2, 6 square. Okay. So we can write what? Possible outcome are there. 2 times throwing a die, 2 times throwing a die will give total number of 2 times throwing a die will give total number of outcomes as what? 6 square, 36. And we can get like this. Okay. So the sample space is given by, how can we write this? S equals to In set builder form we can also write it. So our first term 1 times what? 1 1. That is a pair shows the outcomes 2 times throwing. That is first pair will be 1 1. Second 1 1 1 2 1 3 1 4 1 5. So 1 1 1 2 1 3 1 4 1 5 1 6. This is 6 first time. Similarly 2 1 2 2 and here 2 6 and so on up to what? 1 2 3 4, just like 3 1, then 4 1, then 5 1, then 6 1. 6 6 6 6. Just you can write all the values. Last what? 3 6. Here just last what? 4 6. Here 5 2 and so on to 5 6. And here 6 2 up to how many? 6 6. So this is our sample space. We can write this sample space. How many elements are there? 36 are elements. 36 elements or pairs. 36 elements. 1 1 1 2 1 3 1 4 1 5 1 6, and you can complete it 2 1 2 2 2 3 2 4 2 5 2 6 3 1 3 2 3 3 3 4 3 3 6, and here also 3 2 you can write, here also 4 2 you can write. Okay, just 11 you can get 36 elements. This is sample space. It can be written as a set builder form just like this. S equals to order pair xy, where xy may be equal to 1 2 3 4 5 6, such that x and y are equals to 1 2 3 4 5 6. This is set builder form. As a set, sample space is this. This also can be written in detail this. Okay, one order pair represent a outcomes of 2 times throwing a die. So this is sample space. Okay, so this is sample space of question 2. Now here a coin is tossed 4 times. Third question. A coin is tossed 4 times. A coin is tossed 4 times. So 4 times, that means how many possible outcomes will be there? What? Just discuss in the previous questions. 2 3 times, that is 2 power 3. 6 2 times, that is 6 power 2. So here what? 2 4 times, so 2 power 4. 2 power 4 means 16. So 16 outcomes will be there. So how can we find this? How can we write? Okay, we know a coin, whenever a coin is tossed, then there will be 2 faces, either head or tail. So suppose first 4 times, this is first time, right here, first time, second time, third time, fourth time. Okay, so first time we can get what? Head or tail. Clear? Corresponding to this head, we can get head or tail. We can get head or tail. This is second time. Third time. Also we can get head or tail. Head or tail. Similarly, head or tail. Similarly, head or tail. Fourth time, head or tail. Head or tail. Corresponding to this, head or tail. Corresponding to this, head, tail. Corresponding to this, head, tail, and so on. Corresponding to this, head or tail. Corresponding to this, head or tail. Corresponding to this, head or tail. So how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16. So elements can be right. Sample space. How many? Because one outcomes having 6 letters, 4 letters, H. So H. This. H, T. So H, T. H, T, H. H, T, H. H, T, T. H, T, T. Okay? H, T, H. H, T, H. H, T, H, T. H, T, H, T. Okay? H, T, H, T. Now H, T, T, H. H, T, T, H. Here H, T, T, H. H, T, T, T. H, T, T, T. After this. Okay? So 1, 2, 3, 4, 5, 6, 7, 8 are there. Up to here completed. Now with this. T, H, H. T, H, H, H. 3 time H. T, H, S, T. T, H, H, T. T, H, T, H. T, H, T, H. T, H, T, H. T, H, T, T. T, H, T, T. This. Now 4. T, T, H, H. T, T, H, H. Now T, T, H, T. T, T, H, T. T, T, H, T. So T, 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 H. T, 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 H. Now T, 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 T. T, 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 T. This is 16 elements are there. Okay? So 2 to the power 4 is equals to 16 outcomes. 16 outcomes. Clear? So this is sample space. Whenever a coil is tossed 4 times. So by tree diagram you can write the sample space. Okay. Now question 4. A coin is tossed and a die is thrown. You are mixing. Okay. Question 4 for writing sample space. Event is what? A coin is tossed and a die is thrown. Both. A coin is tossed and a die is thrown. A coin is tossed and a die is thrown. this is our experiment, and we have to write sample space corresponding to this experiment. So how can we write this sample space? Just we know throwing die having 6 outcomes, 1 2 3 4 5 6, and throwing tossing coin. If coin is tossed, then either head or tail will come. If coin shows head, then die may shows what? 1 2 3 4 5 6. Tail also 1 2 3 4 5 6. So what will be the outcomes? Just you have to write in details. Okay, just write when we toss a coin, then either of the two faces containing head or tail may come. So, and head means H, tail means T, just denote like this. And addition with this, if we throw a die, then with this head, die may shows any of the numbers. With tail, also die may show any of the numbers. That is with head 1 2 3 4 5 6, with tail 1 2 3 4 5 6. So sample space will be what? Head 1, head 2, head 3, head 4, head 5, head 6, and also tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. So this is sample space. Okay, this is the sample space corresponding to the experiment. A coin is tossed and the die is thrown. Okay, simple. Similarly, question 5th. Here, a coin is tossed and then a die is rolled only in case head is shown on the coin. Means a coin is tossed. Okay, a coin is tossed, and if coin shows a head, then a die is rolled. And nothing says in this question. That is, if coin shows tail, then nothing we will do. Okay, so here, what will be the sample space? Experiment is what? Experiment is a coin is tossed and then a die is rolled in case head is shown on the coin. Experiment. A coin is tossed. A coin is tossed and then a die is rolled only in case a head is shown on the coin. A head is shown on the coin. This is our experiment. A coin is tossed and a die is rolled in case a head is shown on the coin. Suppose a coin tossed and shows head. Then a die is rolled. The die is rolled. The die can show 1, 2, 3, 4, 5, 6 with this head. Obvious tail, then nothing we will do. So what will be the sample space? Head 1, H1, H2, H3, H4, H5, H6 and T. Sample space will be just you will write in detail discussion and then finally write sample space like this: H1, H2, H3, H4, H5, H6 and tail. Also maybe as an outcome, you tell them nothing we will do. If head, then we will roll a die. So Outcome will be H1, 2, 3, 4, 5, 6 and T itself. Okay. Now, question 6. This was the question 5. This was the question 5 for this. Okay. Question 6. What is 6? Question 6 is two boys, two girls are in a room X and one boy and three girls are in room Y. Specify the sample space for the experiment in which a room is selected and then a person. Okay. So take question 6. Question 6. In this question, just our experiment is what? First of all, we have to select a room and then we select a person. So there are given, how many rooms are there given? 2 rooms. Okay. So here, question 6, experiment is what? Select a room and a person. Room suppose this is room X and room Y. Okay. In this room and in this room, two boys, two girls are in the room X. X room is this. Two boys, two girls. Two boys, so suppose B1, B1, B2 and two girls also. So Z1, Z2. We are denoting two boys B1, B2, two girls G1, G2. And this contains one boy. So boy 3 and 3 girls. So G1, 2, then 3, 4, 5. We are denoting boys and girls in the room X1. Clear? Now our experiment. Select a room. Just select a room. We can select X. We can select X and a person. First take this room and then we can select either of these 4. One of these 4. So X B1, X B2, maybe X G1, X G2. Okay, and then we may select room Y, then a person. We may select B2, 3 from this room and also from this room G3, G4, G5. So this will be the outcomes and collecting this will give the sample space corresponding to this experiment. One room having this 2 boys, 2 girls, 1 boy, 3 girls. Clear? So this is the sample space. X B1, B2, G1, G2, Y B3, Y G3, G4, G5. This is the sample space. Okay. Room having 2 boys, 2 girls, 1 boy, 3 girls. These are the notation. Just you have to write in details. Just having, suppose the room X having 2 boys B1, B2, 2 girls G1, G2, and room Y having 1 boy B3 and 3 girls G1, G2, G3, G4, G5. Then if we select any of 2, means X or Y, if we select X, then we can select any of the one of these 4. So this, if we select Y, then we can select any of these 4. This is the sample space collection of this. This may be the outcomes. The total outcomes will be this corresponding to this experiment. Okay. So this type of discussion you have to write in details. Okay. So in this way you can write the sample space corresponding to given experiment. So very important. Just understand how can we identify what is sample, what will be the sample space for a given experiment, and just note down how many, what is a die and coin, and how many faces are there, how many cards in 52 cards, so what types of cards are there, red, black, and what is a spade, clubs, diamonds, hearts, and what are ace card, face card, jack, queen, king. Just uh, revise this topic, and also do all the questions from examples for writing, and also just read deeply for understanding better what are the terms are used for finding probability. Okay, and just let us, we are starting from today this, what is sample space, what is outcomes, what is experiments. Okay, do some all the examples also, and try to do some questions from exercise and examples. Okay, and send me some solutions for your attendance. Okay.